All right, y'all. We got another problem here. Once again, this is from week 9, day 1, classwork. Slide 5. This is problem number 2. So we're solving equations. This one's got an exponential. It's an exponential equation. In general, y'all, when you have an exponential equation, right, and x is in your exponent, you're going to end up trying to use some sort of logarithm to undo that exponential, right? So, and I'm going to do exactly just that here. This is actually a pretty straightforward problem. I'm not even going to need any of these laws of logarithms or anything. If my exponential is base 10, then I just want to use a log, which is also base 10. If y'all recall, that's the common log. So if I ever have, remember guys, if you ever have log base 10 of x, for example, people don't usually write base 10. They just say log x. That's the time when you get to be lazy. The other time when you get to be lazy, remember, is if you have log base e, then that is ln of x. All right. So, but we aren't using e, so we are not gonna, we're gonna leave that out of this. So I am gonna just do a log to both sides here, actually. That's all I'm gonna do. I'm gonna take log of 10 to the 2x squared minus 7. So log of 10 to the power of 2x squared minus 7. And it's going to equal log of 81. This is actually just a, this is something that you can, this is a trick you can do anytime. If you have an equation, you can do the log of both sides, similar to how in the last problem, which if you watch the last video, in the last problem I showed that you could just do an exponential of both sides. And it's because we're assuming like, well, if these are equal, then the log of two equal things should be equal, right? Like, this is the idea that if A equals B, then the log of A should probably equal the log of B as well, right? Because we just did the same thing to both sides. So let's see what happens. Well, if I have the log of an exponential and they have the same base, they actually will cancel each other out. They will cancel each other out, and I'm left with just 2x squared minus 7. And that equals the log of 81. I'm going to leave that there as is. I'm not even going to bother evaluating that right now, because that doesn't really matter too much. We could plug that into a calculator later. So now we just have to solve for x. This is some basic algebra, guys. I'm going to add 7 to both sides. 2x squared equals the log of 81 plus 7. I'm going to divide both sides by 2. That canceled previously. This will cancel. Oh, and I should probably square root it, right? Because I have x squared. Yeah, we'll show the steps. So x squared equals this. Log 81 plus 7. I like to use parentheses, by the way, when I have logs and when I have things like other than just my log, because I find I don't want to get confused, right? I don't want to think that that plus 7's inside of the logarithm. And so then to get rid of the square, I just square root, yeah, right? And keep in mind, guys, whenever you square root while solving for x, whenever you're solving an equation and you square root, you should always put a plus or minus. Not probably, you always should. And so I'm going to be left with x equals plus or minus whatever this is equal to. So to figure out what that equals, I'm just going to go ahead and pull up Desmos on my browser. So let's find desmos.com. And I'm doing the square root. So to type the square root, I use sqrt. And I know that I have a fraction inside my square root. It is the log of 81 plus 7 all over 2. And it turns out that that is equal to 2.11. 2.11. All right. So now I'm going to go back to my whiteboard, and I'm going to say that x is equal to plus or minus 2.11. And that's it. That's the solution there. So the only thing really that this problem was kind of intending to teach us or show us was how you can use logarithms to undo the exponential. All right, don't remember that, guys. Whenever you see an exponential, whenever you see x is in the exponent, logarithms are summoning you. All right. I'll see y'all on the next one.